Hi, I'm RC Jim, and welcome to the first in our series of detailed videos on programming ESCs. Today we're specifically looking at the Cobra ESC and the details of how to program it. Of course, we've already provided for you some general introduction to programming ESCs, both what they do as far as generally, the approach to take in using either a stick or a programming card. But we are now going through individual brands of ESCs and showing you the details. And there are differences with them, and sometimes it's a bit confusing as to what they're describing, and either in the method or just what it is that you're actually changing. And so we'll be going through those sorts of things for you. We'll also be showing you on our test rig just what happens with several of the different parameters, things that you can actually observe. And so you have an idea of what you're actually changing and what that's going to do. So let's get right into it, and then we'll show you what it's all about in programming the Cobra ESC. Now, I mentioned we are going to be looking today at the Cobra ESC. Interesting that this thing comes without any sticker on it or anything to indicate it's a Cobra, so just so that I don't mix it up with something else, I've put a piece of tape on there, Cobra. This is their 80 amp ESC, but I would expect that each of their ESCs are going to be very similar. Now, they do have a programming card that you can use with it. With the programming card, it gives you 6 different functions that you can program, and several options on each of those. But we will note that if we're doing it with a stick, you only can set 3 of the options. And then with each of those 3 things that you can set, you're limited on 2 of them as to what selections you can make. So, for example, with the brake, it's just on or off as far as programming with a stick. With the programming card, you've also got a medium braking setting that you can select. With the brake, the medium is the default. So if you didn't have the card, and you like the medium setting, if you do nothing with the brake, then it'll stay there. But if you program it at all, it's either going to be on or off. With the timing mode, you've got auto and high, but there's no low setting that you can select by using the menu. Of course, auto is default, and most of the time that's going to be totally fine. So that's probably not a particular issue. But nonetheless, just pointing out, you got very limited things that you can do with a stick. What you will note here is that there's nothing on there as far as programming the throttle. As they say in the instructions, that's set to automatically detect what it needs to do and provide a nice linear response right through the range to full throttle. And as I tested it out, I thought, well, let's just see if this actually is really true. And so I went through sort of the normal mode of, putting the stick at 100%, turning on the ESC, pulling it back down to 0, and seeing whether that would change anything. And I tested the motor on the rig before and afterwards as to how far you had to move the stick to get it going and what the full RPM was at the full travel, and it made no difference. So you can believe them when they say that's automatic, and it does seem to do a fine job. The question then is, okay, if you're programming with a stick, how do you go about this? Well, the first thing you need to do is you need to bind your transmitter to your airplane. So you go ahead and go through that procedure. You can see our video on setting up your transmitter if you're unsure about that. But you get it bound so the transmitter is bound to the receiver on the airplane. You then turn off the power on your airplane, so unplug the battery or pull out the safety switch or whatever it is that you have for turning the thing on and off. And so the power is off, no power going to the ESC, but the transmitter is still on. You can then move the throttle stick on the transmitter to 100%, and you want to verify that it's at 100%. And with that throttle stick at 100% and with the safety switch in the armed mode to where the throttle actually is working, with that throttle at 100%, you then power up the airplane. As you power up the airplane, you've powered up the ESC, and that then gives you 3 seconds, and then it'll give you 4 beeps. If you did want to change the brake at that time, you'd pull the stick back to 0, and it would then toggle the brake from whatever it was to either on or off, and then it'll confirm that with either a single or a double beep. The single beep means that the brake is on, the double beep means the brake is off. So if that was not what you wanted, if you wanted the brake to be opposite to whatever it indicates that it is, then you start all over again. You unpower the ESC, make sure the throttle is 100% on your transmitter, power up the ESC, wait for the 4 beeps, 4 single beeps, beep, 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 and when you hear that, take it down to 0. That will then toggle it to the opposite. So it toggles back and forth between on and off with that brake setting. Now, let's say you wanted to program something else other than the brake. Well, you start all over again. So having the power off on the ESC, having your power on the transmitter, and having the throttle at 100%. You then power up the ESC. You hear these 4 beeps, and you ignore that. You don't do anything. The stick is still at 100%. There's a 3-second break, and then it's going to battery type. You'll then hear 5 single beeps. So it'll be beep, 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 beep. Okay? And with that 5 beeps, when you hear those 5 beeps, if you want to select the LiPo-Ion before the 5 double ones start, you move your stick down to 0. So right after you've heard these 5 beeps, 5 single beeps, you move it down. Okay? Given that it's understood that and you've done it in the proper timing and so forth, it'll confirm that with either a single or a double beep. The instructions don't tell you, but I would assume that that is just again confirming where the brake is set as to what it is. Although it is interesting, if you haven't set the brake and if it's still at the default, then neither the single or the double would apply. So maybe I'm assuming too much there, huh? But anyway, in the instructions, they just simply say the confirmation will either be a single or a double beep. Okay, so that's 5 single beeps. But let's say, and of course most likely that's what you're going to have, and that is the default, the LiPo-Ion, that one there. But let's say you wanted one of these other ones. Well, after doing the 5 single beeps, it then goes to 5 double beeps. So it'll be beep, 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 beep. So you got the 5 times double beats. When you've heard that, if that's what you want, you move the stick down to 0. And of course, as I talk about moving the stick to 0, technically I suppose it's minus 100 as far as the actual signal on the stick, but down to 0 throttle, okay, the stick all the way down. Okay, in a similar way, if you wanted the LiPo 4, then you'd be getting 5 triple beeps. So beep, 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 beep. And if that's what you want, you then right away pull that stick down to 0 throttle. And that would select that one, and you'd get this confirmation. Now, with any of these selections, after you get this confirmation, you then need to turn the power off to the ESC. And that has got everything finalized. You can't do multiple things at one time. So you set one particular thing, you turn the power off on the ESC. If you need to do another one, then you get your throttle at 100%, put power to the ESC, wait for the beeps to go along until you get down to the item that you want. I do note here that, up here with the brake you got 4 beeps, and all the rest of these are groups of 5. And this goes from 5 singles to 5 doubles to 5 triples to 4 at a time, quads, and then 5 at a time, beep, 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 beep. I'm doing that 5 times, okay? That's what that 5 by 5 is all about. And so for any of those, the one that you select is right after you've heard that number of beeps, you just pull the stick down. Okay. So that's basically how you do it with a stick. So let's now get into our test rig and actually go through it and show you what it does. Okay, here we are with our test rig set up. We've got motor mounted on our little cart here. We've got a stop to where it can't go away if something comes loose. Got it tied up back here with a scale in the system so we can measure thrust. We've got a watt meter in the circuit so you can see what the amps are. The little clamp that's holding on the stop there also serves as a backstop should the prop go backwards and decide to push it backwards a bit. Yeah, so everything's nice and safe. We've got a receiver. Our ESC is plugged into the number 1 slot in the receiver. The brown is on the bottom, where, like with any servo, is how you have it. This is not powered up, but I have just tested it, so it is been bound with a transmitter, and the transmitter is working. So right now everything is safe. I've got the switch in safe to disable the throttle, and I've got the throttle at nothing, but that's not how we want to do it for doing the programming. So what we're going to do is we're going to arm the throttle to where it'll work. We're going to hold on to this. We're going to put the throttle up at 100%. We're then going to plug in the power as we continue to hold it. And we listen. Okay, so we got our confirmation. So that was 4. Okay, there's our 5 single ones. Now we're going into doubles. Now we're into our triples. Okay, oh yeah, got the 5 ones. We're into 4. Okay, and we're into the 5s. So that's a high timing mode. And if we're wanting to select that, we would then move the stick to 0. And we got boop beep. So that's a double beep, confirming that it's all set. We then take this one off. Okay, so that was set the timing mode to 5. And we could have set any of those things that we wanted to something different. We just simply, at the time when the beeps are going on, we move the stick down, and that's what we get. So pretty simple and straightforward with that. Well, even more simple is what to do with regard to the program card. Now with the programming card, as we've showed you, you've got the different things listed there is what you can do, and you've got these little jumper things. It just connects any 2 of the things together. And with each of these segments, you got a certain number of pins and you got a certain number of selections. If there's 3 selections and you have the jumper thing in the middle, then it's picking the middle one. If you've got it connected to the top 2, then it's indicating it's the top one. And if you want the bottom 2, it's going to be the bottom one. So with this, you just simply set up everything the way you want it. So the battery type is going to be a LiPo, and with this one, it's the middle setting. Keep in mind that's not the case with the programming stick. With that, the LiPo is the first setting. This one's the second one, but it tells you quite clearly right there. Cutoff voltage. What the cutoff voltage has to do with is what amount of volts it's going to is going to trigger the ESC to either cut the power to the motor or to reduce power to the motor. Okay, so you've got a little chart there on the instructions that tells you what's going on with this, and get it to where you can see it here. Okay, So we've got, for high cutoff voltage, it's going for a LiPo, it's going to cut it off at 3.2 volts. For a medium one, it's going to cut it off at 3 volts. And for the low one, it's going to cut it off at 2.8. Now, myself, I wouldn't even go down to 3.2 before, as far as what I want to target when I'm flying. I'm quite happy to quit flying with it at 3.7, get someplace close to storage voltage, But with some of my planes, they're rather power hungry, and so I need to run them more, and so I might get them down to 18% or something like that. But that's still above 3.5, But with this cutoff voltage, this is not something you ever plan to have to use. You ought not to be flying your plane up until the time that the thing says, oh, we're running out of power here, we got nothing left in the battery, we better, slow down or whatever. I know some people like to do that. If that was the case, I'd definitely be picking the high voltage, because just in terms of what it's doing to your battery, it's just not healthy to be running it down that low. And have a look at the instructions on your battery and see what it says about what the lowest voltage is that you ought to go to, and it'll be much higher than this. Okay? So you ought not to be using this as a plan for how you fly. You ought to be using your timer for how you fly. But given that this is just a fail-safe safety type thing, I'm not comfortable with 2.8 volts, but I'd probably say medium would be fine, the 3 volts, and not that I'm planning on going there, but nonetheless, that's probably okay. Okay? So it's a safety thing, and the thing will still work at that sort of level, so that's probably okay. Now, the next item on here is, after the cutoff voltage, is a cutoff type. So with a cutoff type, on this bottom one over here, that has to do with whether it's going to just simply totally immediately cut off the power to the motor when it gets to that voltage level, or whether it's just going to slow down. And naturally, the slow down mode is a much safer one to pick. And you see that you've got a cutoff mode as those first two items, and then below that it's got a change of rotation. I was very confused about this at first, but in actual fact, the cutoff mode is the first two choices, and the change of rotation is a totally separate item, and yet there's just the one jumper thing for both of them. So, change rotation, of course you can just swap two wires on the motor to change the rotation of the motor. But you can also do it with this, but you've got to do it in 2 steps, is what I've worked out by experience. So let me take you through those. First off, let me show you how this performs with the setting as it is currently. Okay, so currently we've got a slow down mode for the cutoff type, and we've got a medium cutoff voltage, and we've got a the brake is off, okay, and currently it's rotating the correct direction. So let's show you what that looks like. Okay, so we're all bound. This has been in the safe position, so we get ready to go. Okay, so it's blowing air towards me, and you can see the brake is off. Okay, so rather quick throttle. Just looking to see what the throttle mode is. It's on high, or no, sorry, timing mode is high. Acceleration is actually on the medium setting. Okay, so that's how that's set up right now. So we get everything safe, we unplug it. Okay, now what I'm going to do is I'm going to reverse rotation. So I'm going to take this little guy here, and we've got down at the bottom change rotation. So I'll put that jumper on the bottom two, So as we have it there, so the jumper's on the bottom too, for change rotation. Everything else I've left the same. So I now plug that in, brown lead on the bottom. I power it up. And now notice we're getting 2 beeps repeatedly rather than just 1 beep to confirm it. Okay? Now I think what they're doing there is they're giving you a warning that you've changed the rotation, you know, with a signal that's different. I haven't read this anywhere, but it's just what I've observed. So they got this continued 2 beep sort of thing happening. And like I say, I think that's a warning that say, oh, what did I do? Did I really mean to do that? Now, the next weird thing is when we go ahead and plug this in. Got a transmitter, everything is safe, it's off, so we go ahead and plug her in. Okay, we got our beep to say that we're hooked up. Okay, I arm the throttle. It's now blowing the air away from me, but notice what's happening with regard to the brake. It's got a brake on that is really strong, you know. So the brake is definitely on, even though, as we look at our card, up here, brake level is off. It's on the top 2, okay, not on the medium, not on the hard. Okay, but having changed the rotation, if I then put this back to set it for the slowdown mode, so for the cutoff type being slowdown mode, and we set that up, okay, we then power up, and notice you just got the single beep. Okay, not the repeated double beeps. Okay, so we set that. Another way again, plug this in again. Okay, we're safe, throttle down, plug her in. Got a double beep confirming that something is happening, which is interesting, sometimes single, sometimes double. Okay, now I get the throttle going. Okay, it's still blowing away from me in reverse, but now it doesn't have the brake on, which is how it was set to begin with. We haven't changed that. The brake is still in the off position, but when we first changed the rotation, it put the brake on, and then we had to program it again with this in a different position, and of course that's cutoff type, so it doesn't have anything to do, well, it shouldn't, you know, that has to do, you know, that's brake and this is cutoff type, and I'm just thinking cutoff voltage, cutoff type, so those 2 things are together. So it shouldn't be doing anything, but it does. So we go through that double thing to reverse the rotation. And so I'm going to want to get it back again towards going the right way. So right now it's going the wrong way. It is going smoothly, but in the wrong direction. So we do our programming again to, this time we'll again reverse the direction. So of course the reverse just means reverse. It doesn't mean it's clockwise or counterclockwise, so this particular program card. Okay, we plug that in. The brake is still off. We haven't changed that at all during this whole time. We plug her in. So now we're getting the double beeps. We unplug it. We get our throttle plugged back into the receiver. Doing a great job on our fuzz with all of the put it on and off. Okay, so we're into the receiver, we're safe, throttle off. We plug her in. Okay, arm the throttle. So now it's going in that direction, but the brake is on. Okay, so we get safe again. Take that off, take this off, get our card off. Say we're in the right direction, so we don't want to change the direction anymore. We put back onto our cutoff type as being the slow down mode. We plug her in, power her up, got a single beep, which would, if it was a stick mode, that would be saying brake is on, but it doesn't seem to have anything to do with it when you're using the card. That's saying it is off. Okay, so now what I expect is going to take place, and we'll see whether Jim is crazy or not. I expect it's going to be rotating in the right direction and the brake is going to be off as we intended it. So let's see if I'm right. Everything's safe. Now we got a double beep. Okay, arm things going the right direction and the brake is off. So how do you like that? Okay, the next item on there is the brake level. And with the brake level, it can either be off, medium, or hard. Medium is a default. Hard is if you say had a sailplane that has got an electric motor to get you up there, and it's got a folding prop, then a hard cutoff is a good thing to have to cause the prop to stop, allowing the blades to fold back in there. Can also be a good thing for a plane that you're going to do belly landings with. You know, you're flying it without landing gear and you're doing a hand launch at the start. By having the hard stop, the prop is going to immediately stop. And as it stops, well, if you're lucky, it'll be horizontal. If not, the props do have a way of just flicking out of the way when they hit, if it's just sitting there stationary. Whereas if it's got the momentum of it spinning around, it doesn't want to stop as easy when it hits something, and it's more likely to break. So it's not a guarantee that you won't break a prop, but it would be better having the propeller stop if you have that type of situation. Myself, I like the off position. For one, that oftentimes I'll have the power off when I'm coming in for a landing, but I just like the idea of the prop spinning around. It makes it look like I'm not doing a dead stick landing and all that type of thing. Having the prop spinning will actually tend to slow the plane down, similar to the helicopter when it's doing auto rotation. That's slowing its descent. And if you've got a plane with the propeller spinning, with this in the off position, that's actually going to add drag and it's going to slow it down. But to me, that's actually a good thing, in that our field has got trees at both ends, and it's a big field, but nonetheless, it seems like a lot of guys tend to land at the last minute and so forth on it. And I like the idea of being able to have a steeper of approach, and having that prop spinning freewheeling is helping to slow that plane down, especially if you don't have flaps, to be able to get it in and get it stopped before the end of it. Okay, so that's the brake level. Next one is timing mode. Now, timing mode is much like the timing in a car. You know, back in the old days, we used to have the distributor. You turn the distributor cap and you adjust, you know, when the spark is going to fire relative to the piston coming up to top dead center. And they always would be firing the spark before the piston got all the way up there, even though you want the pushing to be happening when it's going down. The reason for that is that it does take time for the flame front to move through the combustion chamber to create the pressure that you'll want at the right time to push the thing down. In a similar way, with an electric motor, when you put the power to the coils, it actually takes some time for the current to build up to the point where you get the maximum amount of magnetic flux that's being generated. So you need to fire it a tiny bit, you know, fraction of a millisecond or whatever, but a tiny bit early before the pole gets to the coil, that it needs to be on the other side of it to push it, or, you know, coming up to it, it's going to pull it. But you need it to be a little bit early to allow that magnetism to be generated fully at the right time. Now, with that, with motors such as this one on my test stand here, where you've got lots of poles, it tends to need high timing. And if you don't have it high enough, what it's going to do is going to limit the RPM that it can generate. If the timing is adequate, it's not going to improve it anymore to bump it up even higher. It's just simply going to cause the motor, well, the ESC especially, to heat up more. So that's not a particularly good idea. But the thought would be to have it high enough to be able to generate top RPM, and once you've got top RPM and increasing the timing more doesn't help any, then there's no need to increase it. But a situation like this, all we've got is automatic, high, and low. So with this motor, I would pick high if I was choosing between high and low. But hey, automatic is automatic. So given that it does a good job, I don't have any problem with that. Okay, so that's a timing mode. The final one is motor acceleration. Now, this would have to do again with helicopters or planes with great big props where you're a bit concerned about either the forces that are going into the system, like say the helicopter with all the gears and things. You don't want to be stripping those gears because you gave it such a big whammy all of a sudden. Or in the case of the plane with the great big prop, you might be concerned about the amount of amps that it's going to generate as it gives that big whammy to get that prop spinning. So with either of those, you want to have the lower end of motor acceleration. So for the helicopter, definitely low, which very slowly winds it up. Or with the plane with a great big prop that you're worried about the amperage being generated, to medium. Or with most sport planes, to have that instant response and make things happen straight away, the high, it would be fine in situations like that. So we set these things the way we want. So I've got the LiPo selected. I've got, in terms of cutoff voltage, that's on the medium. On the cutoff type, I've got the slowdown. Brake level, I've got off. Timing mode, I've got set on auto. And motor acceleration, I've got on high. So those are the particular ones that I want. It's basically, I've just got two of them that are set different than the defaults, but nonetheless, those two things are what you do. Well, then we've got connectors up here at the top. So on this side, you've got 3 prongs, and that's where you're going to plug in the ESC. On this side, if you didn't have a BEC, battery elimination circuit, that's going to power this one, then you'd need to add 5 or 6 volts over here on this side to provide power to the unit. What we then do is we've got the power disconnected here. We take our throttle signal lead, we plug it into the program card. You see that it's got a negative on the bottom there, so the dark one, in this case brown, is going to be corresponding to the negative thing, and we can get the thing plugged in there. So that just goes onto those 3 leads like that, and then all we have to do with that in place is just simply add power to it, keep everything nice and safe. And we have the 2 beeps indicating that it's confirmed. And with the 2 beeps, we're saying that the brake is, well, it would normally be in an off position, and actually this is in an off position. So that's confirming that. So that's all it takes in using the programming card, and that's programmed. So let's now have a look at what happens with different settings. So right now we've got the brake in the off position, so there's no brake. So let's have a look and see what that is like with the brake off. So we plug in our receiver. Transmitter is still on. Everything is now safe because we're using this like normal. This is all safe. We're all hooked up. we power things up. And now the question is, what is the brake going to act like? So we arm our throttle. Okay, and you see that is a nice slow coming off. And of course, if it was going through the air would be pushing it. So we put our safety switch on again, throttle is down. We then take off our power. Okay, now let's see what happens if we put the brake in the hard position. So, well, actually, before we plug it in, brake, breaker 19. Okay, brake level, we'll put it in the hard position to show the extreme. We're then going to plug this in, get the brown on the bottom. Okay, brown in the bottom, that's plugged in. We then add the power to it. And you notice that's a single beep now. So that's indicating that it's been set to the brake being on. Get our receiver and number 1. When plugging these things in, you got a little indentation on the bottom, and you can use that to help guide it in. Sometimes it's otherwise hard to line it up, similar to the issue that I was having there. Okay, so now we've got the brake in the hard position. So that again is on, everything is safe. We plug in this, and now we arm the throttle. And you see how quickly that stops? Right away. So that's the idea of the brake. Of course, the medium would be in between those two. So safe everything, unplug it. Okay, now what else might we want to know what is different? Battery type, can't do anything with that. Cutoff voltage, you can't really test that, at least not in their limited thing here. Timing mode, motor acceleration. Okay, I got that on high. Okay, now let's put that one on low and see what happens with motor acceleration when we put it on low. So we can plug this guy in. Okay, and I'm going to put the brake level back to off. Okay, so we got a motor acceleration on low, and the brake is off. So we now power it up, and everything's safe. Okay, we got one beep saying the brake is on. Single beep, the brake is on. Double beep, the brake is off. If we were using the stick to program it. Okay, this says that you'll just hear one beep. So that's not telling us about the brake thingy, but I'm pretty sure we heard 2 beeps there one time, so I was figuring that was what that's telling us. Okay, so we've now got the brake is off. The top position there is off. We've got motor acceleration at low. Okay, and we'll just make sure that that again is in there. Okay, got a single beep. We then plug this into the receiver. Brown on the bottom, number 1. Connect that up. There we go. Okay, everything is safe here. We plug in our power. Okay, so the question is, with low motor acceleration and the brake off, what's it going to be like? So we arm our throttle. And you notice I put the throttle all the way up right at the start, and yet it took quite a while to get going. Okay, and then back down again. And you can see again we've got the brake off, so it's taken a nice while to get wound down. Okay, so that's pretty well everything we want. I'm just checking that everything is the way. Oh, I don't want the low acceleration. Let's show you what the medium acceleration is, just for kicks. Okay, so that's now on medium, brown on the bottom. That's plugged in. Single beep, it's all good. We now plug it into the receiver. Brown at the bottom, line up the little thing on the bottom. It's all good. Okay, everything's safe. We plug in the power. Okay, and this is medium motor acceleration. Just checking that. Yeah, medium acceleration. So here we go. Arm the throttle. Okay, so not instant, but nonetheless better than slow. Okay, so that's why I like the more instant one. You know, why wait for the... Having said that, there'll be some planes that are very torque sensitive, and to immediately bang it with full throttle. I mean, you've heard the stories about the Corsair, the real life Corsair, you know, Widowmaker, killing pilots because they ram on the throttle too quick and the thing spins out of control. But I think with our radio control planes, most of the effect of the propeller on the roll of the airplane is going to be the rotating airflow that comes back and hits the tail surfaces. But nonetheless, even with that being the case, if it takes longer for that to happen, it gives it a little bit more time to get accelerated, or it's got better airspeed and it's less impacted by it, that might be a good thing to have. So leave that one up to you as to what you prefer. Well, that pretty well does it as far as programming the Cobra ESC. Trust that that's been helpful to you. If that's something that is something that you like and you want to be able to see the other ones that we're going to do, hey, subscribe to our channel and it'll all be handy right there. In the meantime, you might have a look at some of our other videos that are up, and you'll find a lot of helpful tips and tricks. Well, I'm RC Jim signing off. You have a great day.